Good morning, good afternoon, depending on where you're joining us from. Definitely appreciate you joining us here for this webcast. My name is Rick Walsworth. I'm the Vice President of Product and Solution Marketing here at Vexata, and joining me is Ganesh, who is our Principal Database Architect, our resident Oracle guru. And today what we're going to be doing is we're actually going to walk you through a fairly detailed presentation looking at hybrid transaction and analytical processing, and otherwise known as HTAP, and called many things across the industry, but effectively it's the ability to be able to operate in a transactional processing mode where I'm doing heavy transaction processing, and we're actually going to give you some real-world use cases on this, but then the ability to be able to perform analytic processing on that same data. And what are the requirements, what are the challenges, what are the things you need to overcome when you're looking at doing hybrid transaction analytic processing? What we're going to do, though, today is actually walk you through a detailed explanation of what HTAP is in the environments, take a look at some of the best practices for being able to architect Oracle hybrid database environments, and then show you specifically how Vexata maximizes these transaction and analytical workloads in a real-world environment. As we get started here, what I want to do, though, is just give you a quick background on who Vexata is. Actually, Vexata has been around for about 4+ years, now been shipping product for almost a year, and what we do is we essentially unlock how enterprises access data at scale. And this is an important concept, especially when you're looking at providing support for Oracle environments, in transactional and analytic environments, and obviously as you start to bring those two together, you need the ability to be able to provide high IOPS at scale, and that's effectively what we do. The company was founded by Zahid Hussain and Surya Varanasi, who are industry veterans, and they work together across a number of different companies, but when they were working at EMC, they really discovered that there was a market opportunity that was being unserved and something that was going to be very difficult to do within a existing vendor in the industry. And that's really what was the genesis to be able to start Vexata. And so they took this idea and this architecture concept and presented it to leaders in the VC community, such as Lightspeed Ventures, Mayfield, and Intel Capital, as well as Redline Capital Management. And these are companies that really have a background in taking and creating multi-billion-dollar value creation by marketing disruptive technologies and taking these investments around things such as big data and software-defined networking and cloud. Well, essentially, this is the opportunity to be able to bring those same capabilities now into storage, and that's really what Vexata is working to do. The systems that Vexata is actually now shipping in the market are called the VX100. And the VX100 actually, it comes in two separate form factors, really addressing a different set of use cases and performance parameters out across there. We have the VX100F, which is our NVMe flash platform that delivers amazing latency when you look at it in terms of comparing it to existing all-flash solutions, but also provides that latency consistently even under heavy load. And we're talking about the ability to run, sub-millisecond latency, 150, 200 microseconds type of latency, but be able to do so in environments where I'm pushing as much as 60 gigabytes of bandwidth out across there. But we do have some customers that have said, look, that's great performance, but I need to go to that next level. And customers that are either looking at in-memory solutions such as SAP HANA or SaaS VIA. And we've actually, to address that, we've actually been working very closely with Intel and taking their 3D XPoint technology, otherwise known as Optane, and delivering a system called the VX100M, which is a complete Optane system. And what that does is that takes performance to that whole next level by delivering latency as low as 30 microseconds with bandwidth as much as 85 gigabytes per second, scaling out to 8 million IOPS. So this is really that next tier of performance, and that's being driven by a lot of not only core applications that we're going to talk about today, but also applications that you're looking at in the marketplace, such as time series database. These other types of applications are going to drive that next level of performance. So I'll stop here. I'm going to hand it over to Ganesh, and he's going to walk us through the agenda in terms of what we're going to talk about today.
Thank you, Rick. So in this presentation, we quickly review Oracle OLTP, OLAP, HTAP applications, what it does or what it needs from the base solution or infrastructure. Then we will deep dive onto HTAP key requirements. Then we will see a demo on Oracle HTAP application performance with Vexata VX100M Scalable Storage Array. Then finally, we will take Q&A. First, OLTP application. So OLTP application does short transactions by large number of concurrent users. It does frequent data loads and data maintenance operations. And it requires quick response time. In other words, or in industry terms, it requires huge IOPS, huge throughput, and low latency. So short transactions usually involve small amount of data and time. A typical OLTP transaction takes a second or less and uses a couple of data blocks. Concurrent users can access the same data at the same time. As an example, consider an OLTP application that supports Thanksgiving Day sale. In this application, a popular product can be seen or bought by thousands and thousands of users at the same time. So, how do we measure transactions and concurrent users within Oracle? If you take Oracle AWR, AWR stands for Automatic Workload Repository, you could measure transactions and concurrent users in various ways. The load profile section and instance activity stats shows transactions in two different ways. In load profile section, you can see transactions per second, and instance activity stats, you can see transactions by commits or rollbacks. In Oracle, a transaction is measured by either commit or rollback. In the same instance activity stats, concurrent users can be measured by logons or logouts. Now, frequent data loads and data maintenance operations. So the frequent data loads could be your small or medium application processing loads. It could be your daily, monthly loads. Consider any application that requires data to be loaded at the beginning of the day for processing. For your data maintenance operations could be transmitting data to your standby or backup systems, running backups, or data reorganization tasks. Some example for data reorganization tasks could be your index creation, index rebuild, and data archiving, purging, compression, and creating partitions, etc. Finally, the OLTP application needs faster response time. Consider, as an example, consider an OLTP applications that support airport check-ins and bank deposits withdrawals, instant online surveys. All these applications that short transactions by large volume of concurrent users, and it requires instant response time. So how do we measure response time? In Oracle AWR, response time can be also seen as latencies, read latencies and write latencies. So in this example, we see DB file sequential read as a read latency and DB file parallel write latency as for data writes, and log file parallel write for your redo log write transactions latency. And also, Oracle Enterprise Manager Cloud Control shows single block read latencies. So in summary, OLTP applications require huge IOPS, huge throughput, and low latency. Now let's move on to OLAP. OLAP application does high throughput with preferably low response time. Think of an example here, as shown here. The database, OLAP database, simultaneously supporting ad hoc users, and ETL processing at the same time. So how do we measure latencies and throughput in OLAP applications? Like OLTP, in OLAP, we could measure read latencies in direct path reads and DB file sequential reads. The writes can be direct path writes, and the read, the other example for the read is DB file scatter read. So you can measure the throughput in IO profile section. In this example, we see approximately 1 gig write and 40 gigabytes per second read, and together 41 gigabytes per second read plus write throughput. So in summary, OLAP applications does small number of users but long transactions, and does large volume of data scans. So far, we reviewed OLTP and OLAP features at very high level. So let's move on with the HTAP application. So now let's consider this scenario. Our management team asking us to explore HTAP, also known as a real-time analytics option, because they say the conventional ways are not working. The marketing team says OLAP data is not current because analytical decisions are being made on old data or stale data. Too many versions of same data in the database, and it's very confusing. The infrastructure team says redundant infrastructure in terms of storage and servers. Duplicate data is stored at many places. The operational team says they are supporting too many jobs and too many tools, and it incurs too many licenses and support costs. So now let's explore HTAP application. So consider a well-tuned OLTP solution. An OLTP solution has various components: database, storage, network, security, etc. But for this presentation, let's consider the top two components, database and storage. And also consider an OLAP application, a well-tuned one. So here, what do we mean by a well-tuned solution? So consider in database component, few parameters and options. First one, let's talk about block sizes. So in OLTP, we use a smaller block sizes, typically 4K and 8K. For OLAP applications, we use larger block size, typically 16K, and even now people started using 32K. In OLTP application, we use buffer cache, DB flash cache as a caching options. OLAP applications might not benefit from caching options. OLAP applications extensively use parallelism, and OLTP application not use parallelism. So OLTP application favors indexes, and OLAP application favors full table scans. Let's move on to storage components. Like block size, in storage also the block size, volume block size matters. The other two are really important to consider. IO type. The IO type could be either sequential or random, and IO mix could be read intensive or write intensive. I remember when I was working as a DBA, whenever I put a new storage request, storage admins ask what type of IO is going to happen on the new storage. Is it going to be sequential or random? And what type of IO mix is going to happen? Is it read intensive, write intensive, or mix? In case of mix, what would be the mix? Is it 50-50, 80-20, and so on? So why they ask, the important to remember here is that not all storage array would support any type of IO and IO mix. So in summary, HTAP is a superset of OLTP and OLAP. To summarize again, OLTP requires high IOPS and low latency, and OLAP requires high throughput, and HTAP requires all three, IOPS, latency, and throughput. So let's deep dive onto HTAP key requirements. The HTAP solution should support effective data consistency, concurrency, and data integrity. So what do we mean by consistency and concurrency integrity? Let's consider this example. We have an Oracle table with 8 rows with few data blocks in each row. Consider an analytical user 1 comes and scans all data blocks in row 1 to 4. At the same time, Analytical user scans all data blocks from row 5 to 8. Remember, it's an HTAP application, so an OLTP user comes, and while the scans are happening by the Analytical users, the OLAP user changes a couple of blocks. Again, the another OLAP user changes few other blocks. Now, third user comes and changes the block changed by transaction user 1 and changes another block. So now the important thing to know here is, in this example we see a couple of OLAP users and a couple of transaction users, but in real time the OLAP users could be 20, 30, and the transactions user could be in thousands. So it's not only users, and batch processing can come and change the blocks. So it is important to make sure that the proposed solution provides consistent data image to each users and processes, and it supports concurrency. Coming to the integrity, all these transactions either can be interrupted or it can get successfully completed. So in either case, the solution should provide data consistency and concurrency and make sure it maintains the integrity, data integrity at all time. So here, Oracle maintains consistency and concurrency and integrity. Let us see how it does. So Oracle uses multi-version concurrency model and various other types of locks and transactions. So these methods ensures that consistency and concurrency and integrity is maintained all the time, and most importantly, it ensures no data is blocked for read-only queries. So let's see a quick example. Let's say user runs select star from customer where some criteria. So when this SQL enters into an execution stage, let's assume for this example, Oracle uses statement level read consistency algorithm. So the statement level read consistency algorithm required SCN. SCN stands for system change number. So let's consider for this example it requires SCN 500. So also consider the statement, the SQL requires 9 blocks with the SCN 500. So block 1, block 2, no issues because block 1 has SCN 500 and SCN 500, block 1 and block 2, and block 3, when it tried to scan block 3, it notices that somebody changed the SCN from 500 to 501. So it goes and fetches the previous image from the undo or rollback segment. So and so on. This is just quick an example, and Oracle uses various other methods to maintain the consistency, concurrency, and integrity. So now let's move on to other HTAP requirement. The solution should handle dynamic workloads without configuration changes. That means one configuration should make sure that OLTP and OLAP run together. Let's consider, an HTAP application supports all these type of functions. It could be a call center OLTP function, your batch or ETL jobs, analytical query, and the data maintenance jobs happening at the all time. So the solution should support all these ad hoc workloads or processes without having to change the configuration for each one of them. So here, Oracle Vexata solution handles the dynamic workload because Vexata Array is capable, as Rick mentioned, Vexata Array is capable of handling any type of workload. It provides similar performance for your sequential or random workloads. And also, it is capable of handling any type of I/O mix patterns. It doesn't matter whether it is high read intensive or write intensive or mix, it provides a very good performance. So now move on to another HTAP requirement. The solution should have a better cache management. Consider these two examples. In HTAP, OLTP, we know that OLTP applications benefit from caching. When I say caching, it could be your buffer cache or a deep flash cache. So OLAP applications might not benefit from caching, but it can bring unnecessary data blocks to the buffer. I have to say here, not all OLAP queries can bring data blocks to the buffer. For example, your direct path reads will not bring data blocks to the buffer. But in order to get the consistent OLTP performance, we have to make sure that the OLAP queries, doesn't evict the OLTP buffers from the cache. So we have to make sure that it does. So Oracle and Vexata solution provides better cache handling. How? So Oracle provides flexible options to handle the cache. The keep option maintains the buffers from the eviction. So what that means is that we can force keep buffers that required for OLTP transactions without having to worry about OLAP transactions, getting evicted those buffers. Vexata provides a near memory performance. Vexata volumes can be used as a flash cache destination. So it can dynamically increase the cache capacity to fit the needs of the application without additional hardware. And Vexata volumes are also faster, and it provides near memory performance. The other key requirement is the solution should handle both OLTP and OLAP features. So we know that OLTP require high IOPS, ultra low latency, and high concurrent users, and OLAP does high throughput and massive data scans, and it does long running queries. So if we want to make sure that Vexata Oracle solution provides HTAP performance, yes it does, because as again Rick mentioned, Vexata provides high IOPS. In my example in Oracle testing, I could see it provides up to 7 million 8K IOPS, and it provides high throughput up to 60 gigabytes OLAP query performance, and it does this massive IOPS and throughput under 1 millisecond latency consistently at the all time. So if I have to, kind of summarize the HTAP benefits, it provides operational efficiency because data doesn't have to move from OLTP to OLAP, and it makes real-time analytics possible because the moment data is entered in your OLTP database, it is instantly available for analytical queries. And also, it provides cost savings because it eliminates the duplicate data and related infrastructure investments. And most importantly, your business decisions can be accurate because business decisions are based on real-time data. So now let's move on to a demo. So for this demo, this is my test bed. So I used Vexata VX100M Optane storage system, and we have 4-node Oracle dual socket servers, 4-node Oracle rack. I used 40 gig Ethernet for the Oracle rack interconnect and 32 gig FC infrastructure for the public network. And again, it's a 6U Vexata VX100 Optane Scalable Storage System. So before we see the demo, I would like to explain what this demo is all about. So in this case, we have, as we know, we have 4-node Oracle rack that's running with the Vexata VX100M scalable storage array. Here we did 2 tests. The first test is meant for DBAs and developers. The first test provided results in transactions per minute and throughput. So I used HammerDB TPCC application for to mimic the OLTP workload, and HammerDB TPCH to mimic the OLAP workload. So TPCC provided 8 million transactions per minute, while at the same time the TPCH did 20 gigabytes per second throughput. We are going to see this one. And the second test, meant for storage admins and architects. So instead of HammerDB TPCC, I used the testing tool SLOP, and the SLOP does intensive physical I/O. And for OLAP, I just used the same HammerDB TPCH. As you see the results, that the solution provide 4-node Oracle rack solution provided 2.5 million read plus write IOPS and 32 gigabytes per second read plus 15 gigabytes per second write throughput. So let's jump into the actual demo.
That's great. And while he's doing that, I've got a number of questions that are already in the queue, so I encourage the viewers to definitely keep the questions coming. These are really good questions. I'll let him go through the demo because some of the questions may actually be answered by the demo. But yeah, highly encourage you, if you have questions, now's your time to go ahead and get those in, and we'll address the questions after the demo.
All right. Thank you, Ray. You can see my screen, right? All right. All right. Let me pause here. So we have an Oracle 4-node rack system is running, one database. I have TPCC data loaded on that database, as well TPCH data loaded. Now here, see on the left-hand side, we have HammerDB TPCC application. On my right, we have HammerDB TPCH application. So both uses VXDB, that's the database name, making sure TPCC and TPCH. TPCC does 300 concurrent users and TPCH does 20 ad hoc users. Running TPCC and TPCH. Let me pause here for a minute. So this is actually an hour test. So just just to highlight here, the TPCC application does approximately 8 million transactions, and the TPCH does 20 gigabytes plus large reads. So here we are making sure that the same performance what we have seen from the Vexata UI is reflected on the Oracle Enterprise Manager. So as you see on the background, you could see the large reads up to little over 20 gigabytes per second, and also the TPCC you are seeing 8.3 million transactions per minute. This, by the way, this is about 1 hour test. I'm just going to show you a 30 minutes snapshot and 1 hour snapshot. So as you see here, let me pause here. So after 30 minutes workload, the average bandwidth read is about 22 gigs, you could see here, and the TPCC performance is about 8 million transactions per second. The amazing thing is the latency. As you see, the array, you see 85 microseconds read latency and write 85 microseconds read latency. That's one of the, the best performance, the 4-node rack can provide in any of your tests or benchmarks you have seen in the past. So now let's move on to the next test. So here I replace the TPCC application with the SLOB OLTP workload. Let me run it. So the OLTP workload is running. So let me pause here. As you see at this point, the OLTP workload is running. The OLAP workload is not even started. But you see from the Vexata UI, you could see close to 15 gigabytes per second read and about 17 gigabytes per second write. So this is because the SLOB tool does Oracle updates. An update involves reading a block from the storage and changing the block into some other value in memory and writing back to the storage. So each update involves two IOs, one read and write. So here it reads about 15 gig and writes about 17 gig. The 2 gig is for additional metadata or log writing. This is pure OLTP performance. At this point, we have not even started OLAP. So let's run OLAP on top of it. So now the OLAP workload TPCH is running. Look at the performance here. So it could do after 30 minutes, this is I'm showing a dashboard after 30 minutes. So an average performance, it could do 37 gigs reads throughput and 15 gigabytes per second write throughput. And also it does 2.5 million IOPS, and with an amazing latency of 112 microseconds read and 86 microseconds write latency. Now, this is a 30 minutes snapshot. At the end, we will see a 60 minutes. Now, I'm taking an Oracle AWR while it is running. And now let's pause here again. So it confirms 4-node Oracle rack is running. So for the better viewing experience, I highlighted the AWR numbers on your right. So here, if I start running, you have 4-node Oracle running. That it validates. And in this section, it highlights the latencies. See, for this example, here you see DB file sequential read is about 416 microseconds. That's what I captured here. And similarly, I captured DB file write, or your write latency, and log file parallel write. So Oracle AWR shows all latencies under 500 microseconds. Now again, this is your host machine stats. If the host machine does 4.4 million physical reads and 1.6 million physical writes, and this is your IO profile section that shows your bandwidth information. Here, it shows 13.7 MIB, it's approximately 14.4 megabytes, and 35 gig MIB, it's close to, 35,000 MIB, that's close to 37.6 gigabytes in reads. So together, it comes close to 50 gigabytes reads and writes as shown in Oracle AWR. So this is our 1 hour runtime dashboard. As you see, after 1 hour, the solution provides a consistent performance of 36 gigabytes per second read, 15 gigabytes per second write, 2.5 million reads and write IOPS, and the latency, all this 1 hour, it's a consistent 112 microseconds read latency and 85 microsecond write latency. So this is not something I'm showing a 5 minutes or 30 seconds hero numbers. As you see, this is 1 hour consistent performance.
Well, not only that, but I think what's important here that you just pointed out, Ganesh, is that you've got very good correlation between what's being reported at the Oracle host within AWR versus what's being shown on the dashboard here. And this is performance under load, right? So this isn't, like you said, these aren't hero numbers. These are actual performance numbers running under a very heavy load.
Right. So that concludes the demo.
And so while he's going back and as we do a wrap-up here, again, thanks for everybody that's asked questions. I'm just going to go through the questions and start reading them off. You want to just do a quick, we'll just do a quick summary as we do that. Again, a couple resources that are posted here as well as posted up on the Bright Talk channel to be able to kind of take that next step. We do have an Oracle solution page, so you just go to vexata.com/Oracle, and all of our Oracle resources are posted up there. And one of the things, I mean, we showed you kind of a recorded demonstration just because of the complexity of the setup and whatnot, But one of the things that we find that customers really get benefit from is an actual live demonstration. So anywhere on our website, you can actually schedule a live demonstration, and we'd be happy to do something that's more specific to your environment to be able to optimize it to your specific needs and requirements within there, as well as we can actually sit down and do a TCO assessment. So the TCO assessment is just the ability to be able to take a close look at what your current infrastructure looks like, what your current needs are, and then how can we do that. And then obviously, as we go forward, certainly follow Vexata Corp. It's at Vexata Corp on Twitter. You can also follow us on LinkedIn as well, again, just for updates as we go forward. So a couple questions came in, I think, that are really good, some of which you've already spoken to, Ganesh, but a couple here that I think are new that would be good to share with the audience. So if I already have OLTP running today in my environment, and then I want to add Analytics or OLAP as part of that, is this a process that's disruptive?
Let me take this one in two ways. If you have your OLTP running on Vexata already and would like to bring OLAP to the same infrastructure, then I would suggest reviewing the legacy OLTP and OLAP infrastructures, and also make sure that the existing OLTP infrastructure has the capability to support the OLAP workload. Or if you are planning to move your OLTP infrastructure to the Vexata, then combine with the OLAP at later stage, then I would recommend working with Vexata sales and customer support to review the legacy infrastructure and get suggestion on the proposed solution. But in either case, it will not be a disruptive upgrade. Right? You can move OLAP modules process in order to be safe, you can move the OLAP modules one at a time to make sure that the transition is smooth.
Okay, great. And then the other question came in here because I think you used Optane in your setup, right? So we use an Optane array in the setup. So the question here I think is a good one. Is that do I need Optane SSDs in order to make HTAP work, or can I just use standard NVMe flash?
You can use standard NVMe flash. Vexata with Optane provides a better latency number than regular flash. So Vexata with the flash provides similar performance but slightly high latency. Yeah. If your application requires a latency, if it is really important to you, then I would strongly recommend to use Optane.
Right.
But the performance, in my test, I have not seen any difference between Optane and flash.
And if you compare it to existing all-flash arrays, I mean, even at